This video will demonstrate how to use the redox half reaction method to balance this reduction-oxidation reaction. The very first step is very important. It's the thinking step, because you have to come up with a separation of the full reaction into two half reactions that are capable of being balanced using this method. And in this case, it gets a little bit entertaining because the counterpart for our lead 4 oxide has chlorine in it, which requires me to use the chloride ion. And our second half reaction will also have to use the chloride ion. This is a phenomenon that is referred to as disproportionation. Essentially, we have one thing reacting in two different ways. It doesn't matter for the redox half reaction method, because once we've completed this step of creating our half reactions, we're going to balance everything separately and then recombine. So the next step is to perform mass balance, where we make sure that everything we're using that's not oxygen or hydrogen is properly balanced. So for this first half reaction, I'm going to have to change the coefficient on the chloride ion. And now everything that's neither oxygen nor hydrogen is balanced. The next step is to balance mass for oxygens. I have 2 oxygens as reactant, so I need 2 as product. And in order to achieve that, we use water. The next step is to balance out the hydrogens, and this is because by adding water, essentially recruiting it from the aqueous solution we assume the reaction occurs in, I have ruined the balance of hydrogens. I have 4 here, so I will need to add 4 H+. We assume that we do all of our balancing in an acidic solution, which means that hydrogen ions are in ready supply. So now that all of the mass is balanced, I only have to balance the charge. And let's do that in blue, just to make clear that this is something completely different. And in balancing the charge, it's not about making sure that everything equals 0. It's about making sure that when I look at my half reaction, the product side and reactant side have the same charge. As it turns out, we have 2 negatives and 4 positives, so this is +2 net charge, and here this is neutral. So in order to balance these out, I can add in 2 electrons as reactant, and that balances the charge. So this half reaction is now completely balanced in terms of matter and charge, and the only thing left to do is worry about recombination. But in order to worry about recombination, I have to balance the other half reaction. So for the mass balance, I need 2 chloride ions, and I do not have to do anything for the oxygen balance, so it does not apply. The hydrogen balance also does not apply. And now I only need to balance out my charges. I have a -2 charge and neutral. And because balancing the charges requires that they be equal, I can make this -2 by adding in 2 electrons. And so now what I call the pre-combination step requires me to figure out what I must multiply by so that the electrons that are reactants will cancel out and number exactly the electrons I have as product. And in this case, I must multiply both by 1, since I already have 2 electrons on either side. And so now I can do the full recombination. by writing out my half reactions completely. So this is my first half reaction, and the second half reaction and in this recombination step we want to make sure that we did it right by being able to show that I have the same number of electrons as reactant and product, and they will cancel each other out. I have nothing left to cancel out, and I can now write out everything I have. So in this case, the chloride ions will add up. And it's left to be verified that the number and type of atoms that I have as reactants is equal to the number and type of atoms I have as products, as well as verifying that the charge I have on the reactant side is equal to the charge I have on the product side.